Good morning, students. So previously we have discussed dilations where a figure enlarges or becomes smaller by the rate of a scale factor. And then we've talked about proportional relationships, how you can find measurements of unknown heights or unknown distances using indirect measurement, and then we've talked about transformations to prove similarity, which is different from transformations proving that two figures are congruent, because if they're congruent, they're the same size, and we know that only rigid motions can do that. But this time we're going to talk about corresponding parts of similar figures. Okay, so if we go back and remember the word corresponding, okay, I just want you to think about, when you think about corresponding, as being the same location. It's in the same location on both of the figures. So if I'm looking here at these two triangles, you can tell by the way that they're written, the similarity statement is written, because angle P is going to be congruent to, or corresponding to, angle U, and angle Q is corresponding with angle V, etc. You can tell by the writing of those statements. PQ, that side, is going to be corresponding to UV. That's how you can tell by if it's written. But if you're drawing it, you can also tell that way. So we know that angle Q is going to correspond with angle V. Angle P corresponds with angle U. Angle R corresponds with angle W, etc. Okay? And the same can be said for the sides. So PQ is going to correspond with UV. Notice how those are in the same location, etc. Okay, so we know that. We learned that in our last unit. But the thing you need to know about similar figures is it's going to have certain characteristics. With figures that are similar, we know that they are the same shape, but they are not the same size. Okay? That's when they're similar. So, the corresponding angles of similar figures, I want you to think about a 90-degree angle, okay? 90-degree angle. Say that this side is 2 and this side is 2. Well, if I enlarged it to this side being 4 and this side being 4, did it change the angle? No. So the corresponding angles of similar figures are congruent. But you notice how I changed the sides. So the corresponding sides are not going to be congruent. If you look at QR and VW, let's just imagine that QR is 2 and VW is 4. So we have a scale factor of 2 because we multiply 2 to that side to get 4. But those are not congruent. 2 is not congruent to 4. But it is proportional. Meaning that the relationship, and we learned about this in the proportional relationships. So QR is going to relate to VW in that it's to force, which is 1/2. And that is proportional, okay? And every side is going to be that way. The proportion for every corresponding side is going to be 1/2, okay? So that's what that is referring to. Okay? So let's look here. So therefore, now that we know all of that information, we know that the corresponding angles are congruent and the corresponding sides are proportional. So let's look. Angle P is going to be congruent to angle U. Okay? Angle Q is going to be congruent to angle V. Okay? Angle R is going to be congruent to angle W. So that's how we know that those corresponding angles are congruent. Okay, so now we're going to talk about the sides. So PQ and UV. Oh, let me erase this. PQ and UV are corresponding. Well, let's look at QR. What side corresponds with QR? You might be saying VW. And that's what we would put here. And then what side is going to correspond with UW? PR. So all of those... Sorry guys, I had to pause for a moment. I had a bit of a coughing spell. Had to get some water. Okay? So all of those proportions, that's what these are. These are ratios, proportions, okay? All of those proportions are going to be equal. So if the ratio of PQ to UV was 1/2, then QR to VW would also be 1/2, and so would PR to UW, okay? All of those proportions are going to be equal. Okay, so I want you to pause this, and I want you to try it yourself. Okay, so hopefully you've had a chance to work out this problem so that now we can do it together. So trapezoid ABCD is similar to trapezoid EFGH. So we're going to complete the following statements. So angle B is going to be congruent to angle F. Okay, they're in the same position. They are corresponding, and we know that the corresponding angles of similar figures are congruent. And now let's look at the proportions of the sides. So AB is going to correspond with EF. HG is going to correspond with DC. Need another color. CB is going to correspond with GF. And then lastly, something you want to take note of is you want to be consistent here on the bottom. If your bottom, the bottoms of your proportions are referring to the large triangle or the large figure, then you want to be consistent there. So we want this one to be the last side of the large figure. So it looks like that's going to be EH. And so this top, the numerator, is going to be the smaller figure. Just be aware and stay consistent with that. Okay, so EH, what side corresponds with EH? And you might be saying DAD. Okay, so we know that all of those proportions are going to be equal. Okay. All right, I also want you to pause and take note of this one really quickly. Okay, so the measure of angle J, we're looking for the missing measurements. Okay, so let's look. So we're looking for the measure of angle J. So the measure of angle J is going to correspond with the measure of angle R. But we don't know what angle R is. But something we do know is in RST, we know that angle S is 90 degrees. We know that angle T is 20 degrees. And you may remember this, that the angles of a triangle all have to add up to be 180 degrees. So we can figure out what angle R is. So 90 plus 20 is 110. 180 minus 110 is going to be 70 degrees. So we know that angle R is 70 degrees. Well, then what does that make angle J, because they are corresponding? And we know from the first point that corresponding angles are going to be congruent in similar triangles. So then we know that angle J is also 70 degrees. Okay. Well, now let's look at the side measures. We want to be able to figure that out as well. So we're looking for ST. Well, the corresponding side is going to be proportional. We know that. And the corresponding side to ST is KL. So KL is going to be proportional to ST. Well, we know that the proportions of corresponding sides are equal. So let's look at another set of corresponding sides and see if we can figure that out. Well, we have JK and RS. We have both of those. We know that JK is 3, RS is 9. KL, we know KL is 4, but we're still looking for ST. So there's a couple different ways you can solve this. You can try to figure out, well, what can I multiply to 3 to get 4, and then I'll multiply that same number to 9 to get ST. Or you can go back and refer to what you did in probably middle school, and you can cross multiply 9 times 4. Let me get out a calculator. 9 times 4 is 36. And then 3ST. ST is the value we're looking for. Well, we divide both of those by 3. And then, so ST is actually going to be 36 divided by 3, which is 12. So ST should be 12. So now let's do the same thing for finding the missing value of the other one. Okay, so now we're looking for JL. Well, we know JL is proportional to RT. And we can use one of the other ones that we have. So we had JK and RS. Okay, well, JL, we don't know what JL is, so we'll just leave that. RT, we know is 15. Okay, JK was 3 and RS was 9. So we can do the same thing that we just did. You can cross multiply. However, you can figure out this proportion. So 15 times 3 is 9JL equals 15 times 3, which is 45. Divide both sides by 9. JL equals 45 divided by 9, which is 5. So JL, we know, is 5. Something I do want you to notice here is that we can try and determine the scale factor. So how do you get from 5 to 15? You multiply it times 3. 3 to 9, you multiply it times 3. And 4 to 12, you multiply it times 3. So our scale factor, if you were looking for it, is 3. All right, that concludes the rest of this video.